When you're navigating the sheer complexity of Kubernetes, really understanding how data works, how it persists, how configs are managed, how secrets stay secret, it's just, well, fundamental. Cutting through all that noise and getting straight to the core. That's really our mission for this deep dive. So today we're digging into Kubernetes volumes. These are the crucial bits that decide how your containers actually store and manage data. And we're focusing on four really common, really important types: emptyDir, hostPath, configMap, and secret. This deep dive is based on those great sources you shared titled Kubernetes Volumes, emptyDir, hostPath, configMap, and secret explained. Our goal here is to pull out the most important nuggets, get beyond just definitions and really understand their strategic value. So let's explore what these are, why they matter so much for data and config, and then get into the fascinating details of how they actually work behind the scenes.
Okay, so to really ground this, let's start with the basics, the core idea. Kubernetes volumes, fundamentally, they're there to store and manage data for your containers, right?
They make sure data can stick around or be shared if needed. Because let's face it, a container without the right data access isn't very useful. And the key thing is, different volume types exist for, well, very different reasons.
That's exactly right. It's the perfect place to start. So let's quickly outline these four. First up, emptyDir. Think of this one as like a temporary scratch pad. It gets created when a pod starts on a node, and critically, this is the main point, all the data inside it. It gets wiped the moment that pod leaves the node. So it's really ideal for those short-term storage needs, maybe caching web data or, intermediate files during some process.
Okay, temporary scratch pad. Got it.
Next, hostPath. Now this one is different. It directly mounts a file or a directory from the actual host node's file system right into your pod. It does let containers access specific storage on that node, but, and it's a big but, it ties the pod to that specific node. That makes it way less portable. You'd use this for maybe accessing node logs or specific system tools on the host itself.
Ah, okay, so much more niche.
Definitely. Then you have a configMap. This type is built to store your non-sensitive configuration data. Think key value pairs, maybe entire config files. Its main job is to separate your application settings from the application code.
Which is huge for flexibility, I imagine.
It's
Yeah.
exactly. Makes things much more manageable, like providing environment variables or config files without having to rebuild your container image every time. And finally, secret. This one's, well, it's pretty similar to configMap in concept, but it's designed specifically for your sensitive data. We're talking passwords, API keys, TLS certificates, that sort of thing. Secrets are stored within Kubernetes in a base64 encoded format, and then they get mounted into pods as volumes. The idea is to keep sensitive info secure and separate.
Right, like feeding a database password to an application securely.
Precisely. Supplying credentials or certificates without hard-coding them. So yeah, just to recap quickly, emptyDir for temporary stuff linked to the pod's life, hostPath for talking directly to the node's file system, configMap for everyday config settings, and secret for your sensitive credentials. You define them in your pod spec, and they show up in your containers as directories or files.
That's a really clear breakdown of the what. So naturally, the next question is why? Why are these specific types so critical? What's the real impact they have on managing data and config, especially in these dynamic, containerized worlds? This is where it gets really interesting, I think.
It really is. Understanding the why shows their power. Take emptyDir. Its purpose is straightforward. Provide temporary storage within a single pod. This is super useful when containers in the same pod need to share data temporarily, like maybe a web server writes logs that a sidecar container processes immediately, or perhaps some kind of multi-step data job within the pod. The key insight: emptyDir kind of encourages this idea of not sharing anything long-term within the pod itself. It pushes persistence concerns outwards, which is, pretty core to good cloud-native design.
Right, keep the pod ephemeral.
Yep. Exactly. A machine learning example might be a pod using emptyDir for intermediate training data during one run. Doesn't need it after the pod finishes. Now, hostPath. Its purpose is enabling access to the node's file system for system-level things. Think monitoring agents that need to read varlog on the host, or tools interacting with node-specific hardware or resources. But the critical thing to grasp with hostPath is, while it gives you that low-level access, it fundamentally breaks that Kubernetes promise of node-agnostic portability.
Because it locks you to that one machine.
Precisely. It creates this tight coupling. So it's really not great for general applications that need to scale or move easily. You reserve it for tasks that must interact with the node itself, like that monitoring agent example. Never for application data that needs to survive if the node fails or the pod moves.
That node dependency with hostPath really does sound like a major architectural choice. Are there situations where it's basically the only option, or should you almost always look for alternatives for, say, general app data?
That's a great question. And yeah, for general application data, absolutely, you should pretty much always prefer more portable solutions. Things like persistent volumes backed by network storage, right? hostPath is really for those specific system-level jobs. Maybe a daemon set collecting metrics from the host, or a privileged pod needing direct hardware access. It's a tool for node interaction, definitely not for your standard application persistence needs.
Okay, that clarifies the trade-offs there.
Yeah, so moving to configMap. Its purpose is that clean separation of config from code. But the why it matters goes deeper. It's really pivotal for enabling modern practices like GitOps. By putting configs in config maps, you can version control them, deploy changes to settings separately from your code updates.
Which speeds things up immensely.
Totally. Faster deployments, better audit trails, fewer image rebuilds just for a config tweak.
Yeah.
Imagine a web app loading its port or database URL from a config map. You can update that config map often without touching the application deployment itself. And then secret, purpose, securely store and provide sensitive data. This is just non-negotiable for security in distributed systems. Much like config maps, getting sensitive stuff into secrets lets you manage, version, and deploy credentials independently and, crucially, more securely. It's essential for protecting things like passwords or API tokens. You encode them, you restrict access using Kubernetes features. That database client needing a password, it gets it from a secret, not from an environment variable or baked into the image.
Okay, so given how crucial these seem, what happens if you don't use them? What are the immediate problems you run into?
No, it gets messy fast. Without them, managing even temporary data, accessing node stuff, or handling configs becomes way harder and, frankly, less secure. Think about hard-coding configuration, or worse, secrets directly into your container images.
Oh, yeah, nightmare.
Exactly. Every tiny change of port number, rotating a password being a full image rebuild and redeploy. That's a huge drag on operations, kills agility, and is a massive security risk, right? Embedding secrets in build artifacts is just asking for trouble. And without emptyDir, even just sharing temporary files between containers in the same pod becomes awkward to manage. So yeah, connecting it to the bigger picture, these volume types are really fundamental building blocks for making robust, secure, and flexible applications in Kubernetes.
That really drives home just how necessary they are. Okay, so we've got the what's and the why. Now, for anyone wanting to actually use these, the next step is the how. How do they work behind the scenes? You mentioned they're defined in the pod config, usually YAML, right? And then mounted into containers as directories or files. That connects the app to the data source.
That's the basic flow, yeah. Let's walk through the mechanics for each. For emptyDir, when the pod starts, Kubernetes creates a new empty directory right there on the node where the pod is scheduled. It's usually backed by the node's disk, although you can tell it to use memory sometimes. Then all the containers within that same pod can read and write to that shared emptyDir volume.
Okay, shared within the pod.
Right. So, for example, you might have a web server container and a log processor container in the same pod. They could both mount the same emptyDir at, say, ttim plugs to share log files temporarily. But the key detail for you, the listener, is remembering that this data is gone when the pod is deleted. Poof. So absolutely not for anything you need to keep long term.
Got it. Strictly ephemeral.
Then hostPath. This works by, well, directly mapping a specific path from the host node's file system into your pod. So if you tell it to use varlog from the host, your container sees varlog as a directory it can access. The classic example is that monitoring pod mounting the host's varlog to read system logs. But here's the caution flag again. If that pod gets rescheduled to a different node.
It suddenly sees the new node's varlog.
Exactly. Which might be totally different or empty or whatever. It can cause real confusion if you're expecting data from the original node. It just hammers home that node-specific nature and the dependency risks.
Right. Okay, so let's pause on configMap for a sec. You mentioned a web app loading settings. If I update that configMap object in Kubernetes, does the app see the changes instantly? Or does the pod usually need a kick, like a restart? That seems pretty important for those GitOps flows.
Excellent question. Yeah, very relevant for GitOps.
Hurry!
So when you update the configMap object itself, Kubernetes is pretty good about propagating those changes down. It usually updates the actual files inside the mounted volume in the running container fairly quickly.
Okay.
However, whether the application running inside that container actually picks up those changes automatically, that totally depends on the application itself. Some apps might be built to watch config files for changes and reload automatically. Many aren't.
Ah, so the app needs to be aware.
Exactly. Often, the simplest, most reliable way to make sure the app uses the new config is to trigger a rolling update or somehow gracefully restart or reload the application process within the container. So Kubernetes delivers the updated data, but the app has to actually use it.
That makes sense. There's a gap between the data being there and the app consuming it.
Precisely. So for the configMap workflow, you create the configMap object in Kubernetes first with your keys and values or whole files. Then in your pod spec, you mount it as a volume. Those keys and files then just appear as regular files inside a directory in your container. Your application code just needs to read those files. Simple as that. So that config map with port 8080 mounted at etc config, the app just reads its second config port.
Okay, straightforward enough.
And finally, secret volumes. Very similar workflow. You create a secret object in Kubernetes. You put your sensitive data in there. Kubernetes will store it base64 encoded. Then, just like a config map, you mount this secret object as a volume in your pod. The sensitive data appears as files inside a directory in the container. Your app reads these files to get the credentials it needs.
Like reading the password file.
Exactly. That pod needing the database password. It mounts the secret at, say, etc secret, and the app reads the password file from etc secret to be password or whatever you named the key. But here's that critical security point again. Secrets are encoded, usually base64. They are not encrypted by default within Kubernetes etc data store.
Right, encoding isn't encryption.
Not at all. It's just obscured. So relying solely on secrets isn't enough. You absolutely need strong role-based access control RDAC policies to control who or what can even read those secret objects. Maybe even look into etc encryption at rest or external secret management solutions for higher security needs. Understanding how these work down to this level really highlights their strengths, but also, their specific limitations and the operational things you need to think about.
Okay, so pulling this all together, what does this mean for you, the learner, trying to make sense of it all? Maybe a quick mental model helps here. Think of emptyDir like a temporary scratchpad. Use it, then toss it. hostPath is like opening a direct window onto the node's file system powerful, but use with caution due to the node dependency. configMap, that's like your external settings file, making config changes much more agile. And secret is your secure vault for sensitive info, keeping it separate and protected, but remembering that encoding isn't encryption. Ultimately, each of these volume types makes managing data or configurations in Kubernetes significantly easier because they're purpose-built for specific jobs in that containerized world.
That leads to pretty interesting thought, though. We've talked about how secrets are only encoded by default, needing extra security layers like RBAC, and how hostPath ties you to a specific node, hindering portability. So, given these built-in characteristics, what further considerations or maybe more advanced strategies become really crucial if you're aiming for truly robust data management and security, especially in these very dynamic, distributed Kubernetes environments where your applications might need to scale rapidly or move across different nodes, maybe even different clusters or cloud regions?
That's a fantastic question to leave us with, really pushing beyond these fundamentals. It definitely invites more exploration into advanced data management and security patterns in Kubernetes. We hope this deep dive gave you a solid grasp of these core volume types. Definitely something to reflect on as you build out your own applications. Thanks for joining us.